Sketch the curve y is x cubed plus 3x squared minus 24x plus 20, showing all stationary points, oblique points of inflection, and the y-intercept. I think the y-intercept is the easiest thing. So let's do that first. Remember, that occurs when x equals 0. So that implies that y is 20. So our y-intercept is at 0, 20. If there's a mark for that, let's get that straight away. So, stationary points. So we need dy dx equal to 0. So dy dx is going to be 3x squared plus 6x minus 24. So if we want 3x squared plus 6x minus 24 is equal to 0, let's divide through by 3 to make that easier. So that's x squared plus 2x minus 8 is equal to 0. And I think we can factorize that. So x and x, if we put in 4 and 2 and make this one a plus and this one a minus, that does the trick. So x is negative 4 or x is 2. So if x is negative 4, y is going to be negative 4 cubed, so that's minus 64. And then we have 3 lots of 16, so that's 48. 24 times 4 is 96, and it's a negative negative, so plus 96. And add the 20 on. So let's just check that we've got that right. This one would be positive, this one would be positive, positive. So let's just go and do the calculation quickly over here. Actually, let's just use the calculator to speed things up. We wouldn't necessarily have a calculator for this question. So we've got 48, add 96, add 20, and we'll take off 64. So that's at 100. So we've got negative 4, 100 as a turning point, and x is 2. This should be a bit easier. So y is going to be equal to 2 cubed, 8, plus 12, take away 48, add 20. So 20 and 20 is 40, take 48 is negative 8. So we've got 2, negative 8. Okay, so now we want to know the nature of these points, and we want the oblique points of inflection. So for both of those we're going to need the second derivative. So differentiate this one again and we get 6x plus 6. So let's look at the stationary points first. So evaluate when x is negative 4. That gives us a negative, and that implies that we have a max at negative 4, 100, and then d2y dx squared evaluated when x is 2 is going to give us positive, so that's a min at 2, negative 8. And remember how this works. We know that when the second derivative is negative, the curve is concave down, and that's how we get the maximum. And here, when it's positive, we know it's concave up, and that's how we get the minimum. So let's put d2y dx squared equal to 0. That means that 6x plus 6 equals 0, which means x is equal to negative 1. And so we can get coordinates to substitute negative 1 into here, so that will be negative 1, add 3, add 24, add 20. So that's 44, 47, 46. And now we have all the information in order to sketch the curve. So what we're going to need are some axes. Remember, this is a sketch, so it doesn't need to be to scale or anything, just needs to show the important features. So the maximum is at -400, so let's put that there. And we've got a point of inflection over here, -146. And we know the y-intercept is 0.20. We know that we have another stationary point here at 2, -8. So let's say that's here. And we know the shape of this type of cubic. Well, we know that there's a maximum here, so it's got to come up, take its maximum, come down through the point of inflection, and then start turning towards this other turning point here, and then it will go up like so.